Hello coding enthusiasts! We're thrilled to see our community growing, and we want to give a big shout out to all our new subscribers coming from the Bong Physic and Wanderlust YouTube channel. Your support means the world to us. If you're new to our channel and haven't subscribed yet, we'd love for you to join our community. Click the subscribe button right now and don't forget to turn on the notifications so you won't miss any of our upcoming content. Now, let's get down to business. Today, we're going to delve into a topic that's fundamental to any programmer's toolkit: C++ functions. It's a fascinating subject that can simplify your coding process and help you tackle complex problems with ease. So sit back, grab a cup of coffee, and let's start this coding journey together. Ever wondered how C++ functions work? How they streamline the coding process and make it easier to solve complex problems? Well, in the next 8 minutes or so, we'll embark on an exploration of this vital feature of the C++ programming language. Begin with the basics. A C++ function has a specific structure. It starts with a return type, which indicates the type of value the function will return. Next comes the function name, followed by parentheses that may enclose some parameters. The function's code lies within curly braces. Let's dive deeper and look at a practical example. Imagine we have a function written in C++ programming language named add. This function is of integer return type. What it does is it takes in two integer parameters, adds them, and returns the sum. Now let's look at how this function is written in code. Int add int a int b. Int sum equals sign a plus b, return sum. Let's break it down line by line. The first line, int add int a int b, declares our function. Int indicates that our function will return an integer. Add is the name of our function, and inside the parentheses, we have our parameters int a and int b, which are also integers. In the next line, int sum equals sign a plus b, we have a new integer sum. This is where the magic happens. This line adds the two integer parameters a and b and stores the result in the variable sum. Finally, the line return sum is where our function delivers the result. It returns the value stored in sum, which is the sum of our two parameters. That's how our add function works in C++. It takes two integers, adds them, and gives us back the result. Now, move on to the advanced part. C++ offers two types of functions: built-in and user-defined. Built-in functions come with the C++ library, like the main function. User-defined functions, as the name suggests, are created by the programmer. Let's delve into the topic of user-defined functions. These can be categorized into four types. 1. Function with no arguments and no return value. Here's an example. Let's look at a function that prints a simple message: Python def greet, print hello world. In this function, def is used to define the function named greet. There are no arguments in the parentheses, and it simply prints out the text hello world. This function does not return any value. 2. Function with arguments and no return value. For instance, we can have a function that takes in a name and greets that person. Python def greet to name, print hello plus name plus. In this function, name is the argument. The function takes this name and concatenates it with a greeting message and then prints it out. Again, this function does not return any value. 3. Function with no arguments but a return value. Let's consider a function which provides the current date. Python import datetimedef, get underscore date, return datetime date today. Here, the function get underscore date does not require any arguments. It calls a function from the datetime module to get the current date and returns it. 4. Function with both arguments and return value. An example could be a function that calculates the area of a rectangle. Python def calculate area length width, return length asterisk width. This function takes in two arguments, length and width. It multiplies these two values to calculate the area of the rectangle and returns this value. Now, I hope these examples have clarified each type of user-defined function for you. Before we dive into the beauty of C++ functions, make sure to watch our introduction video, Why C++. You can access this video by clicking the I button of this video. The true elegance of C++ functions is encapsulated in their reusability. The benefit here is that you only need to write a function once, and you can invoke it multiple times thereafter. This approach not only saves significant time, but also results in a more streamlined, cleaner, and comprehensible code. Let's illustrate this with an example. Consider the following line of code. Int add int a int b. This is a prototype for a function named add. Each part of this line has a specific role. Let's break it down. Int is the return type of the function. This tells the compiler that our function will return an integer value. Add is the name of the function. This is what we will use to call the function in our code. Inside the parentheses, we have inter int b. These are the parameters that our function will accept. A and b are variables that will hold the integer values we pass when calling the function. In conclusion, this function prototype declares a function named add, which takes two integers as parameters and returns an integer. This gives the compiler an understanding of what the function looks like and how it can be used. Understanding function overloading is crucial too. In C++, two or more functions can share the same name but have different parameters. This is known as function overloading and is a way to perform different tasks with the same function name. To illustrate this idea, let's consider the following example. C++ void print int I count. Printing int endl void print double fat pi count. Printing float fit endies void print char to se count. Printing character say endl. In this snippet of code, we have three functions all named print, but they each take a different type of parameter, an integer, a float, and a character respectively. In the first function, C++ void print int I count printing int endl. We define a function that takes an integer as its parameter. When called, it prints out the string printing int followed by the integer. Next, we have C++ void print double f count printing float. For an endl, this function is similar, but it takes a floating point number or float instead. When this function is called, it prints printing float followed by the float. Finally, we have C++ void print char c I count printing character ki endl. In this function, the parameter is a character or char. It prints out printing character followed by the character when called. This is a simple yet effective demonstration of how function overloading works in C++. Depending on the parameters type, the program will decide which version of the print function to use. Recursive functions certainly add an intriguing layer of complexity. A recursive function is one that calls itself a potent tool for solving problems that can be broken down into smaller similar subproblems. For instance, let's consider an example of a recursive function in Python. We'll create a function to calculate the factorial of a number. Python def factorial n. If n equals sign 0, return 1 else. Return n asterisk factorial at n 1. First, we define our function factorial with n as the input parameter. This function will calculate the factorial of n. Within our function, we have an if-else condition. The base case is if n equals sign 0. In factorial calculation, the factorial of 0 is 1. So when n equals 0, we simply return 1. However, if n isn't 0, we fall into the else condition. Here, we return and multiplied by factorial n 1. This is where the magic of recursion comes in. Our function calls itself, but with a different argument. Instead of n, we pass in n1. This process continues, reducing the value of n by 1 each time until n reaches 0, where we then return 1. So for example, if we were to call factorial 5, it would calculate it as 5 asterisk 4 asterisk 3 asterisk 2 asterisk 1, giving the result of 120. This is a simple demonstration of how a recursive function works. Each line of code has a purpose and contributes to the overall functionality of the algorithm. Lastly, let's talk about inline functions. An inline function is a function that is expanded inline when it is called. When the inline function is called, the entire code of the inline is inserted or substituted at the point of the inline function call. Let me provide you with a more concrete example. Consider the following code: C++ inline int multiply int a int b return asterisk b. In this example, multiply is an inline function. The keyword inline before the function tells the compiler to perform inline expansion. That is, instead of referring to the code of function using a function call, The compiler places a copy of the function code at each point in the code where the function is called. So if we call multiply function in our code like this, C++ int result equals sign multiply, 1020. The compiler will replace this function call with the body of the multiply function itself. C++ int result equals sign 10 asterisk 20. This copy-paste operation performed by the compiler is known as inlining, thus the name Inline Functions. This process can make your program run faster because it saves the overhead of a function call. So there you have it, a detailed example of an inline function. We hope this helps you understand better the concept and how to use it effectively. To summarize, C++ functions are blocks of code that perform a specific task. They can be built-in or user-defined, and user-defined functions can be further classified into 4 types: function prototypes, function overloading, recursive functions, and inline functions are advanced concepts that extend the functionality of C++ functions. Remember, the power of C++ functions lies in their reusability and ability to make code cleaner and easier to understand. So there you have it, a journey from the basic concept of C++ functions to the advanced features. It's a broad topic, but with time and practice, it becomes second nature. And remember, every great programmer was once a beginner who didn't give up. Happy coding!